Oh, that's a cool idea using
Okay, so polar graphing example 2. Okay, this time with negatives.
Sweet.
So let's graph r is sine theta.
Okay.
Right? Because I'm like trying to pick something really easy, right?
Okay, so
Okay, so let me pick something a little bit harder just so I can show you something cool. So let's pick r is sine of 2 theta.
okay.
So that's after the rule, so it's a horizontal compression.
Yeah, so this got compressed horizontally, right?
Yeah, so those are half of it.
Okay, so I have sine, right? But then it got compressed horizontally, so this normally would be at pi.
But it's
Now it's
pi
at
over
pi
2.
Now it's at pi over 2. So this one's at pi over 4.
Yeah.
This is 3 pi over 4.
Yeah.
This guy would be pi. Oh, okay, so this one would be at 3 pi over 2, right?
Yeah.
And then this first back up would be at 2 pi. You guys with me on this?
Yes.
And because I'm running kind of shy on time, I'm just going to graph a couple of these. So let me do this part. So when I step over here, right, in Cartesian land, the blue bit goes from angles of 0 up to pi over 4. So that's these angles, right? 0 to pi over 4. And the radius goes from 0 to 1, right?
Yeah.
So here's 1, here's 0. I'm going
0 to 1.
from angle of 0 to angle of 1. Or sorry, from angle of 0 to 1 when I hit the angle pi over 4.
Right.
So I rotate and get longer, right?
Yeah.
So rotate, get longer. That looks like this.
Yeah.
Just with me on that?
Yeah.
Okay. Next piece. In here, pi over 4 to pi over 2. So that's here.
You go from 1 back to 0.
And we're going from 1 back to 0. So that's going to give me that same picture, but backwards.
Oh.
And then you're going.
So I got this kind of leaf of a petal, or petal of a flower, right?
Yeah.
And then my next thing,
Practice.
I'm in between pi over 2 and 3 pi over 4, right?
Yes.
So that should be in here.
Yeah. And you're going from 0 to negative 1.
And the radii are going from 0, so that's here at the beginning, to negative 1.
Yeah.
So if I told you to turn to 3 pi over 4 and walk negative 1, you would turn to 3 pi over 4 and then you would walk backwards. So you would end up down here.
Wow. Make sense?
You guys see that?
Yeah.
And you would do that in between these, which means that really you're in here.
Yeah. Makes sense.
You guys see that?
Yeah.
So you're getting this petal.
And then I go from 1
And then in the next one,
negative 1 to 0.
you'll go 3 pi over 4 to pi, right? So that's in here, which really is in this one.
Yeah. And then you go back to 0.
And you're going back to 0, so you're getting petal back in.
Rock.
That's sine.
How many of those would you have to do to make a flower?
That's interesting.
Cool. How many would I have to do to make this whole flower?
You just keep going.
2 periods.
Yeah, so I keep going until I get to 2 pi, right? Until I go all the way around.
Yeah.
Or until I get to a full period, right?
Yeah.
So if we did 2 periods and then we
So
added-
that's 2 periods there, right? So I'm good if I go to just 2 pi.
if we added like another period after that, would it just start overlapping?
Yep.
You'd have to
If I
do
did
some
the
sort
next
of-
period, it would just overlap.
You'd have to do some sort of compression or shift to make it like in a
So
chain.
do flowers follow this?
You guys cool with this? So
Fibonacci.
here's your flower. You could draw the rest, I trust.
What's this one called?
This one's called a flower.
Oh.
Yeah.
The other one had a cute name, so I don't know. That's
Flavoid.
No, it's
I'm gonna name myself.
Floweroid?
Flowerwood.
I don't know what it's called.
Fluoride. Fluoride.
I'll be about botanicoid.